Hi all, now we are going to see understanding ROC curves, PD, PFA, SNR, and pulse integration. Quick definitions, very short. PD, probability of detection, chance the radar correctly says target present. PFA, probability of false alarm, chance the radar incorrectly says target present when only noise exists. SNR, signal-to-noise ratio, target signal level divided by noise level, often shown in dB. Higher SNR easier to detect the target. How PD, PFA and senior relate, ROC idea. An ROC, receiver operating characteristic, curve plots PD, vertical axis, versus PFA, horizontal. Each ROC curve is drawn for a fixed SNR. Moving to higher SNR curve shifts the ROC upward or left. For the same PFA you get a larger PD. Trade-off, for any fixed senior, increasing the detection threshold lowers PFA but also lowers PD. ROC shows that trade-off across all thresholds. The left table plus plot, single pulse, tell you table rows show example SNRs and the PD you get when PFA is fixed at 1e⁻⁻⁶. From the plot and table, with a single pulse, no pulse integration, you need about 13 dB senior to achieve PD almost equal to 0.9 for PFA equals 1e⁻⁻⁶. Lower SNRs, 0, 3, 10 dB, give much smaller PD at that PFA, meaning targets will often be missed. Intuition, single pulse detection requires a high SNR to keep false alarms extremely rare while still detecting targets.
The right table plus plot, 10 pulse integration, tell you. The right table and IOC show results after non-coherent integration of 10 pulses. After integrating 10 pulses, the required senior to reach PD equals 0.9 at PFA equals 1 times 10 to the power of -6 drops to about 5 dB. The IOC curves move up. For the same PFA, the PD is much higher at low SNRs than single pulse case. Intuition, combining returns from several pulses makes the weak target signal stand out better from noise. Pulse integration helps. Simple explanation. Integration sums signal energy across multiple pulses while the noise, random, partly averages out. That increases effective SNR at the detector output. Result. For a given PFA you get higher PD, or equivalently, to achieve the same PD and PFA you can operate at a lower SNR per pulse. Practically, this means less transmit peak power or longer detection range with the same transmitter. Practical impact, numbers from the example. Using pulse integration reduced the required senior from ~13 dB to ~5 dB, making the radar much more realistic. Short note on coherent vs non-coherent integration, why non-coherent matters. Coherent integration, if pulse phase is preserved or aligned, give the best SNR gain, but needs accurate phase coherence. Non-coherent integration, power energy summing, is easier to implement when phase varies, or unknown, and still gives big SNR improvement. The example uses non-fluctuating, non-coherent detection. Pulse integration significantly improves radar detection performance by increasing effective SNR, allowing reliable detection at much lower power levels. IOC curves clearly show how PD, PFA, and SNR are linked, helping optimize radar design for practical operation. Thanks and meet you next video. Bye.